Alright, hello everyone. Last time on this programming series, we had a basic drive base set up with PWM motor controllers, and we got a tank drive working, and all's good. We're getting joystick inputs, etc. Now, the next thing we're going to have to do is implement CAN. Now, CAN is basically a different type of connection method. PWM is generally a direct connection between a motor controller and the Robo-Rio, and it's a lot more simplistic. It's a square wave signal, whereas CAN is actually an analog signal that goes through all the motor controllers, and a unique ID is used to assign it. Assigning CAN IDs is covered on the CTRE documentation, so I'd recommend you look at that if you want to do that. It's done through a web-based interface as of 2018. But essentially, it's going to be very similar to Sparks, except they have a lot more options on how they're configured, and that's going to require us to do a little bit more work on our end, but it's going to pay off in the end. So in this tutorial, we're going to convert this drivebase.java from using PWM Spark controllers to using CAN controllers. The most common and most powerful CAN controller is the Talon SRX. And we're going to have to import this, which I did by pressing Control Space. And essentially, a Talon SRX has a lot of features. It's a little more expensive, quite a bit more expensive than a Spark, but it really packs more of a punch. So this also comes in the CTRE libraries, which you should have downloaded before starting these tutorials, but it's separate from WPI_lib. As you can see, the imports from com.ctre.phoenix. So now that we have this, we're going to have to rename this to Talon SRX, and it takes also a value, except instead of this being the port that your Robo-Rio that it's plugged into Robo-Rio, this is instead the CAN ID that you set in the web interface. So for right now, for the purposes of this, I'm going to keep it as 0 and 1, as I did in the robot map, had it at 0 and 1. But yeah, we're going to have to change these Talon SRXs, both these Talon SRXs and both these new functions Talon SRX. So now we're thinking, hey, that's it. We've set them. We have all the features. Not quite. There's quite a few things that you have to do with Talon. We'll fix these errors in a second, but the error, the thing that is not even an error right now that we have to think about is there's a lot of options that have to be configured with Talons. And these are generally going to be the same throughout your robot. They may not be, so feel free not to just do this on an individual motor basis. But what I like to do is, since throughout all subsystems we generally use Talon SRXs, in robot I would have a initialization for the Talons that kind of sets their common features. So yeah, so let's just make it. It's going to be a static function, so we can use it from anywhere, and it's just going to be public static void init Talon, and it's going to take an input of a CAN Talon motor and a encoder ticks per revolution, which we can add that later possibly, but that can be optional. Oh, what happened here? Oh yeah, Talon SRX, sorry. And actually we don't need, we do not need encoder ticks per revolution. I was thinking about something else. There we go. So we can remove, yeah, I would remove this input. And actually these as well. These are not being used right now. There, just clean things up. So in this, there's a couple things we need to do. Now the first thing I would think about is neutral mode. So a motor, when no input is being given to it, or it's being set to neutral, when you're doing .set0, you can do two things. It can either coast, not have tension, or it can break. So we have to set that. That's an actual option that we have to put, which we didn't get with PWM. So we'll do motor.set neutral mode, and we're going to put neutral mode we have either break or coast. So I would do coast. That's just for this purpose of a generalized one. Like I said, if you have some special features you need to do, I would set those individually, but this is just so we have all the normal stuff set, so you get Talons used right out of the gate. Another one I would do is .neutral output, which it's a helpful one. I would put that just so that way it's kind of, when you're outputting it, it's going to be neutral. Um, Another very important one to put in is your sensor phase. So when you have a sensor phase is essentially saying if you that's not how you spell false. If your motor is spinning positively, you're spinning your motor forward, or your sensors, like an encoder mainly, is your encoder going positive or is it going negative? And you're just aligning it. If you say false, it's just standard. If it's true and it is going negative when you're going forward, it'll flip it around so you don't have to worry about it. There's also 2 limit switches that can be added to a Talon SRX. So like I said, you can get an encoder off of the Talon SRX. You can also get 2 limit switches. You have to configure those though. So you have to do motor.config forward limit switch, and you also have to do it for backwards. So the type of limit switch is you're going to have to do limit switch source dot, and we can either have a remote Talon SRX, a remote canifier, which is new this season, or deactivated. But what you really want is a feedback connector. That means that you was put in through a an expansion board, which is pretty standard. The next one is going to be limit switch normal, and this is going to ask, is it normally open or is it normally closed? Which means when in its natural state, is the switch down or open? So generally, for most limit switches that you'd use, it's normally open. And then timeout milliseconds is just going to be 0, so there's no timeout when you have the motors. And there you have it. And I would do the same thing, except I would do it for reverse. So like I said, you can have 2. You can have a forward limit switch and a reverse limit switch. So there you go. Now you've configured both of those. The next thing you want to do is it needs to know that like kind of percentage of when you put dot set 1 or -1, it's going to align to some percentage value. So what you need is to just keep it standard. So this can kind of get confusing. This is why we want to do it here, is you're just going to put in, so that way when you put 1, it's going at 100%. When you're going at -1, it's going at -100%, and then 0 is just going to be 0. You have to configure your nominal outputs, is what it's called. So your nominal output for the forward direction, i.e. 0 to 1, you're going to put in 0.0 and 0 to standardize it. And you're going to do the same thing for nominal output in reverse. Nominal output reverse, 0.0, 0. Oh. That is bad formatting. There we go. And then there's one more thing we need to do. We need to configure our kind of ramp rate for closed loops. So basically, it's a ramp rate is like the number of seconds from your neutral to your like full speed, and then a closed loop is something like a PID control. It's when you want to kind of oscillate. So when you're using a sensor to calibrate what your motor is using. We'll get into how we can use closed loop controls in a bit. For right now, we're going to do config closed loop ramp, and we're going to put 0.5 and then 0. So there we go. Like I said, very complex, and there's a lot of settings. That's why I like to put it in this init Talon function. So that way, when we go to drive base, we can just say robot dot init Talon and just put left motor, and then robot dot init Talon right. And there you go. We have some initialized Talons. Now there are a few things that you still might have to do. First of all, we see that this is an issue, and we'll solve that in a second. But there's another thing. So for PWM motor controllers, the motor controller was just outputting a was getting a PWM signal, and you could actually connect it to multiple. So what you could do is you could take your PWM signal, split it between 2 Spark motor controllers, and then you control both ends of a gearbox. So that way you could just use 1 PWM signal per 2 motors. That doesn't really work with a Talon, so this isn't necessary. Depending on your type of drive base, it might not be necessary, but I know on 4795 we use tough boxes, and those require 2 motors. So that means you're going to need 2 Talons per per side. So we have to make some more. I would do left motor follower and right motor follower. Because generally you don't want these things spinning in different directions. You want them spinning in the same one. And it's going to be annoying for you to set, both of them to go. So the Talon SRX is a really useful feature for this. We're going to initialize these. And I will just... We will need new values for these. In just one moment I will do that. Ooh, this is not looking pretty. There we go. In robot map you will need more values. Left follow. Yeah, I can do 3 underscores. And maybe that'll be 2, and then right follow motor 3. So we don't even have to update these manually, right? We can do you're already thinking, well, okay, now in set, we'll just set the left follow motor and the right follow motor. That we could do that, but that would kind of take a little bit of time. Also, you want to initialize these, by the way, on one side. So, another thing, yeah. So down here we do, left motor follower dot set, right, or something like that. But that's not necessary because the Talons have a follower mode. What you can do is you can literally just type in left motor follower dot follow, and then you do left motor, and boom, any command you give to the left motor, it will apply to the left motor follower. That way, even if you forget, you won't have to ever forget, because if you forget on something like a tough box and one of them spins and the other stops spinning, you could ruin your tough box. So this is just saving you a lot of headache. Additionally, if for example your right motor needs to be inverted from your left motor, very easy to do. You can just do right motor dot set inverted and then just put true. That's not going to be necessary for now, but this is always an option to invert your motor controllers. You can just invert. So very helpful. This is still giving us an error, and that's because dot set doesn't actually set a Talon, because a Talon set function, which I can demonstrate here, takes a lot more. It takes a control mode and an argument, not just an argument. And the Talon control modes have a lot to them. I can show you some right here, actually. It's Talon control. Is it not? Oh yeah, it's just control mode, I forgot. Dot, there we go. So you have current, which does it by amperage, how much amperage you want to go through. Disable just doesn't move. Follower just follows, obviously. Motion profile arc are some complex things to allow them to follow paths that you draw in a separate program. Don't ask me what motion magic does. They added it this year, and I don't know what that does. But position is extremely helpful. Position is, go 5 feet, and then you can configure it to go 5. And we'll talk about position mode. Velocity is also similar. You give it a velocity to go at, it'll go at that. Velocity. Position is very helpful. It takes a little bit of setup with encoders, but it's nice. Percent output is what we were using before, and that's just 1 to -1, which we configured in the robot class. So easier way to do this, something that just kind of gets us. I'm going to rename this to set, because set raw doesn't really make sense anymore. And then we'll do control mode, and we'll just make the user configure that, and then we'll just supply. Oh, we have to import this, yeah. And then we'll just supply the mode, and then. So there we go. Now we have the mode coming in, but this will now in turn break tank drive, because tank drive is thinking set raw doesn't even exist. Now I put it at set, and it's thinking, oh boy, this doesn't get the right argument. So what we have to do now is, we were using percent mode, so we're going to do control mode dot percent output, and format that, and there you go. Now everything is back to normal, but now we're using now we're using Talons, which are a lot more advanced. There's quite a bit more you could do with Talons, but we're gonna get to those in further tutorials. For right now, this is what we want to focus on. This is not necessary. Yeah, thank you so much for watching. There we go. We've now converted it. This is kind of using the new CTRE libs, and I hope you enjoyed. We'll be getting into more of how to use PID on these, and how to overall make use of all these features that that the Talons offer. So thank you so much for watching, and I'll hope to see you in the next part.